Welcome to the latest edition of our Kearney Procurement and Analytic Solutions The Wave of the Future podcast series. I'm Helen Clegg, and I'm joined today by Adam Detwiler and Jeff Staub. Today, Adam and Jeff join me to talk about 3D printing and how this technology has the potential to disrupt markets and industries. Before we get started, a little background on our two speakers today. Adam is a manufacturing associate within Kearney's Manufacturing Centre of Excellence. He has over 5 years of industry and consulting experience spanning manufacturing and supply chain. Jeff is a manufacturing manager also within Kearney's Manufacturing Centre of Excellence and has over 5 years experience in operations leadership and strategic consulting. Adam and Jeff have both recently relocated from the USA to Melbourne, Australia, from where they join me today. Adam and Jeff, welcome to the podcast. It's really great to have you participate in our series. And it's particularly apt that we're recording this podcast on June the 18th, as today is Maker Faire Day at the White House. Today, the White House is bringing together makers in Washington, D.C. to show the wealth of innovations they have created in 3D maker spaces. So with that as our backdrop, let's dive into the podcast on 3D printing and additive manufacturing. Adam, I'd like to start with you and ask you to define 3D printing and the term additive manufacturing. How does it differ from traditional manufacturing?
Hi, Helen. Thanks, and I think it's a great place for us to start. To do so, let's illustrate the differences with an example, and let's consider a large jet engine component. A manufacturer of a jet engine component might buy an initial casting that is roughly shaped like the final product, but has a lot of extra metal in it. So let's call the starting point of that metal casting 500 pounds. To get to the finished product, that casting is going to go through a series of machining operations like milling and drilling and turning, etc. After you go through that set of machine operations, a lot of material has been removed from that initial 500-pound casting, and it's not abnormal for a product like this to finish around, say, 200 pounds. So it's 300 pounds of raw metal material that's been removed or subtracted from the original casting. And that's what people tend to refer to as traditional manufacturing. You start with raw material in a large product that's bigger than what you're going to end up with, and you subtract material away from it that isn't needed with machining and tooling processes. And that's traditional manufacturing, that's subtractive manufacturing. On the flip side, we have additive manufacturing. There's an official definition of additive manufacturing by the American Society for Testing of Materials, and that definition is the process of joining materials to make objects from 3D model data, usually layer upon layer, as opposed to subtractive manufacturing methodologies. That applies to a number of different technologies, though. So whether it's using a laser to solidify powdered metal, applying a bonding agent to plastic powder, or using a UV light to cure photopolymers, all of these are examples of additive manufacturing techniques. But simply put, additive manufacturing is the process that builds a product one layer at a time from scratch, as opposed to traditional manufacturing, which starts big and ends up with a smaller finished product.
Thanks, Adam. That's definitely a useful introduction to 3D printing and additive manufacturing. So, Jeff, over to you. How is this new technology impacting our current manufacturing processes?
I think that's always one of the first questions, and I think the one of the most interesting parts about this is that it's not actually a new process or a new technology. It's been around for about 30 years now, and it's actually been kind of quietly promising to revolutionize manufacturing ever since, but only recently has it kind of made the jump into the mainstream media. And everywhere you look now, you see 3D printing at the Paris Fashion Show. They're sending a 3D printer to the International Space Station. So now it's become such a ubiquitous topic that you think it's a new concept. And really, I think that's driven because it's a bit of a perfect storm right now with a few companies, industrial and engineering firms that are investing heavily in the technology, causing a significant generation leap in a short period of time. You have countries like China and the United States that are also making massive investments to be kind of ahead of the next wave of advanced manufacturing. You have things that are also part of this so-called third industrial revolution, like big data, advanced materials, Internet of Things, and then finally you have the software really catching up and making some things possible that weren't possible just so recently. But when I go back and I think about within the four walls of manufacturing, I see basically three big changes or three big potential right out of the gate. And by this, I just mean this isn't something that's 5 or 10 years away, but something that could potentially go have an impact on tomorrow. So the reason it's been around for 30 years is actually because of rapid prototyping and the process of seeing the physical part to get your product development cycle going. And we've kind of taken that to the next level in branding it as unconstrained design, because not only does AM give you this rapid prototyping capability where you can basically have a hardware hackathon and spend a week and go through, several iterations of a product, which would have taken you months just, 3 or 4 years ago. You also have this, what we're calling design extension. So when you think about, for example, the human bone, it actually has different material density depending on where the stresses of your body impact it. And with additive manufacturing, you can actually set the product up so that you can take advantage of the same concept, reduce the amount of material being used so it's lighter and just as strong. And you see that same concept applied to things like internal webbing. And what some people don't realize is a lot of products are limited by the fact that if you have to go in and get a big machine tool into an internal area of the product, you just don't have the ability to access that. So this whole new paradigm of the ability to design things unconstrained, quickly, is really a game changer. The next piece that I think is really key for the manufacturing four walls is agility. So ever since the initial Industrial Revolution, where people were artisans in their house and we consolidated into big factories, that whole concept has really been driven by big scale to absorb this fixed overhead cost. And there's two elements of that could potentially change. One is you have the ability to flip between new products much quicker. So if you are a Department of Defense supplier, your program gets canceled. If you have invested $100,000 in tooling for that product, you now have a sunk cost, or you have to go through a lengthy process. With additive manufacturing, there is no tooling, so you can actually go to GM or Ford or another industry and say, hey, we have some open capacity, we have this envelope size, we can build to this tolerance and go after that business without having that fixed cost loss. And then in the actual process, what's really driving a lot of scale is you run batches. You run batches because it takes hours to set up a machine and get a product in spec. And because of that, you can only have so much customization. And now you can actually, without the tooling element holding you back, you can go from product to product without having that fixed process holding you back, and you don't have to absorb those hours of setup over a batch size of hundreds of units anymore. So really positive implications there. And then finally, I think the whole concept of inventory and obsolescence management is really big. And I think the example that always hits home for me is Caterpillar is world renowned for its ability to support its tractors out in the field for 30 years, 40 years, and they'll bend over backwards to make sure they have parts available for years after their product is changed to the next generation. They'll try to recreate those products once their inventory is gone over the years and really go through an immense amount of effort. If you could very simply scan that product, have it download into a 3D design and print it, you have the ability just to eliminate all those massive end of generation runs that fill up warehouses full of products and actually increase your service level at the same time. And until this point, those two things were diametrically opposed to each other.
So, Jeff, you've talked about the impact 3D is going to have on current manufacturing processes, but I guess what I want to know is the additive manufacturing process applicable to all manufacturing industries? As I was doing the research for this podcast topic, I came across an example of a company in Slovenia that's constructed 3D printers for printing houses. So, is this sort of thing really going to take off?
It's interesting because it's such a double-edged sword because every day I read about different applications, different potential, and it on the one hand it's incredibly energizing, but on the other hand the practicality of additive manufacturing and the immediate potential is I think being totally overshadowed by its kind of the long-term implications of printing human organs and things like that. So while I get really excited about that, I think the way we look at it is if you think about an asteroid hitting Earth, there's going to be some direct impacts there, and that could cause an extinction event, and those products or those companies could have basically a replacement coming out of additive manufacturing. And then there's other companies that will be adjacent to that, and they'll be part of the fallout, and they'll have to go through an accelerated evolution to take advantage of the changes around them and position themselves to be a survivor in that new paradigm. But I think the idea is to get us really excited, and really our job is to be one or two steps ahead of our customers and the industry, because that's where we can really provide a lot of value. And when I look at things like what GE is doing with their LEAP engine, it's just going to have an unprecedented impact on the industry of additive manufacturing as a whole, as well as aerospace and defense. So they have committed to basically building their fuel nozzles with additive manufacturing. There's 19 on each engine. There's already a backlog of 6,000 engines. So this investment alone, they have had a partner with a 3D printer. They're saying that in order for us to make our cost and improvement targets, we're going to have to create a new generation of AM within the next 2 to 3 years. And that's just the near term. So that alone is incredibly exciting. The nozzle will be, which is currently made from roughly 20 parts, will be made from a single unit. So you're eliminating a ton of assembly time. It'll be lighter, it'll be stronger, and it'll be able to operate in temperatures 20% higher. So the potential here in the practical terms is really astounding, as much as being able to build 10 houses in a day. And I think even when you look at the horizon, they're projecting that there's a potential to reduce the weight of their engine, a single engine, by 1,000 pounds out on the 2020 horizon. And that's just would have such a massive impact on fuel consumption and waste, and really would potentially spring them ahead in terms of a competitive advantage. So that's the stuff that really gets us excited about the topic.
That's all really interesting stuff, Jeff. Thank you for sharing that. So, Adam, what sort of impact is additive manufacturing already having or going to have on companies' value chains? Can you provide some examples?
Sure. So let's start with one example of how it's already impacting or how it's already disrupting a particular industry. We can look at hearing aids as a great example. 14 years ago in 2000, the companies Materialize and Phonak teamed together to challenge the conventional hearing aid production process, which really involves a lot of iterations on getting the hearing aid to fit and work in a patient's ear. And the production process is very manually intensive, building the mold and getting the mold right, and forming and fitting and finishing and inserting the electronics. So it's a very artisan process, and what Materialize and Phonak did was join together to replace that with rapid shell modeling, which was enabled really by the software and hardware advances in AM. So since 2000, we've already seen more than 10 million customers served and counting with hearing aids produced by these new processes that they've pioneered. On the upcoming disruption side, while that is extremely difficult to forecast, some of the things that we are seeing are along the make and the deliver step of the value chains. So first with the make, if you look at Shapeways, the company Shapeways, and the marketplace that they've established, this really leans on sort of the customization aspect that Jeff was referring to earlier. So Shapeways is enabling customers to go on, and as long as it can be 3D printed, that customer can make whatever product they want at whatever color, whatever size, whatever weight that they want that can fit within a Shapeways printer. They can buy it and have it shipped directly to their house in a 1-unit quantity. There's no minimum batch size. There's no need to go to a contract manufacturer and work out agreements. Also on the make side, there's certainly the potential for whole segments of a value chain to be redefined. So for example, we think back to where we started the podcast talking about jet engine components. And so as the material deposition rate of additive manufacturing printers continues to increase, along with other digital technologies, and the printers themselves become larger, it's not really that hard to imagine a shift from demand for large metal castings that require significant machining to an increase in demand for additively manufactured parts that require minimal to no finishing work. So as long as you're given the right envelope size of a printer, the correct material characteristics to be printed, and the right cycle time of the printer, the economics of this shift could become very real much sooner than many people think. And then finally, another piece that could happen is looking at the major logistics companies internationally. It wouldn't be difficult to take the imagination to a point where your favorite logistics company decides to invest in purchasing 3D printers and bringing them in-house. And not only will they then be the go-to partner for getting products to customers, they all of a sudden transition into an adjacent market of building the products for the customers and then shipping them to the customers, which is just a major change from where we are today. They become a fully capable manufacturer with full distribution capabilities within the channels that they operate.
And Adam, what about barriers to market entry? How are these changing? You've talked about the traditional manufacturing processes and how it used to be, it did used to be very difficult to enter due to high startup costs, etc. So how's that shifting now?
Yeah, sort of like what Jeff said, there's a little bit of the gimmick where anybody can get into the game, and that really depends right now on the materials that you're trying to use for your particular products. But certainly there are fewer barriers in front of a designer or a new entrepreneurial startup company to get your products to the masses. So that really becomes more accessible in two ways. One is as we see technology costs fall and make additive manufacturing more accessible, what you will ultimately see is many, many more people investing on their own in buying household 3D printers. So individuals can personally invest in the low to middle grade printers with a variety of capabilities. They can then quickly and easily iterate on their own designs, get the products into the hands of potential users for market feedback, and without ever having to touch a non-disclosure agreement with a company in a foreign country to manufacture a minimum quantity of their first design iteration, they have a product out there. Two is the proliferation of the manufacturing marketplace, like what I was just referring to as Shapeways. So that could mean a major full-scale 3D printing houses or the development of many smaller local setups for entrepreneurs to have access to the most cutting-edge technology without the need to invest millions to build their own factories.
We've talked about how additive manufacturing is impacting the manufacturing industry as we know it today. But Jeff, how is it changing consumer markets?
Yeah, that's another good question, Helen. I think there's a few ways that you could answer that question. Adam mentioned Shapeways as kind of the 3D printed marketplaces where you have basically kind of the Etsy equivalent of additive manufacturing. You have Staples, Office Depot, and other companies offering home printers that are DIY. If you break your soup ladle, you can go ahead and just print yourself a new one. And if you want to design it yourself, that's even better. You also have, endless hours that I can self-attest to on the internet of just incredible open innovation that has been done by anywhere from a 17-year-old kid creating a very advanced prosthetic to experts collaborating and massive companies, going back to the GE example, that crowdsourced part of their jet engine and got, I think, responses from 56 countries to provide designs and actually reduce the weight of the product. So I think all those things are giving that end user more say in the products that they're interested in and what they're going to actually consume. But nothing in my mind compares to the customization piece. So the concept of customization, which is actually was born out of lean manufacturing, coming out of World War II, Toyota didn't have a large market for its cars, so they had to figure out a way to be leaner and smarter about the way that they gave variety. And we've been able to create some segmented customization, but additive could give you the potential to do true customization. And I think the Phonak example of hearing aids that are made from molds of your ear is just one of many, especially medical applications that are extremely exciting. And when you think about that, I guess the next logical progression is how far away are we from dropping into the mall, going into an Apple store, getting a mold of our inner ear, having it scanned, and having them print a customized set of earbuds while we go eat our lunch, and that kind of real mass customization that end users are willing to pay for and crave is pretty exciting. And I think there's so many examples of that out there with hip replacements that are customized based on your actual bone structures. You have the ability to create scaffolding for skin grafts or burn victims or accident patients in different situations. And then the ultimate end goal here is you have companies like 3D Systems teaming with Google to produce customizable smartphones by 2015. We're really interested in the next steps, but it is so exciting to think about the possibilities, to think about Amazon instead of being a place where products come together. It's a set of additive manufacturing printers, and you can send them your customized iPhone case design and have it delivered via drone in 24 hours. So I guess I'll give myself a little chance to feed to the hype for a second, but those kind of changes for the end user are pretty achievable, and maybe it's 2 years for some and 5 years for others, but they are coming, and they're coming maybe a little faster than people anticipate.
So, Jeff, if these advances are coming down the pipeline and we're talking only a couple of years away, how can manufacturing companies start to prepare for 3D printing? What advice would you give them?
As you can probably tell by our enthusiasm and passion around the subjects, we've put just a massive amount of thought into this, and we've looked at it now two different ways. First, we looked at it from an industry agnostic point of view and said, what are the exec level implications of additive manufacturing? And we've come away with basically 7 what we call strategic advantages. And the reality is they are potential advantages, but they're also potential disruptors and potential problems depending on where you sit in the value chain. And the second piece of work we did was really around the product view, which I think helps begin to have the understanding and the implications, because the immediate reaction is, how could that possibly impact my product? So when we look at, say, the cost of goods, and you look at material as the base of that buildup, you see where are there high cost of materials or high wastage of materials. So Adam mentioned the aerospace and defense industry. So there's a thing called a buy to fly ratio. So how big is the block you buy, or how heavy is the block you buy versus how heavy is the block that actually ends up on the frame of the airplane or the engine. And if that's a big ratio and you're dealing with products like titanium that's $30 a pound, or Inconel that's in the hot section of an engine, just a small improvement there brings additive to a really competitive point of view with traditional manufacturing. And that's really what it's about. How does traditional manufacturing look like it's going to improve? How fast is traditional manufacturing going to improve? And how long is additive manufacturing going to take to catch up? So you have a material point of view, you have the setup time and the actual labor associated with the product. So if you're spending 16 hours welding 2 items together and you can print it in one shot, that's a massive opportunity that should be considered. And then finally, when you look at the distribution network, as Adam said, you're really trying to say, if I'm moving this product around because sourcing from a low-cost country to take advantage of a labor arbitrage, if I can eliminate that labor, I can eliminate the need to really create a lot of waste of movement, the sustainability of shipping things around the world because of the cost of labor. So those elements, I think, are across the board the things that companies really need to get out in front of much sooner rather than later. And I think as a company, we're starting to see more and more industries and companies come to the table and say, help us understand how we're going to be impacted by this. And we're really able to kind of co-create some really interesting scenarios for their future.
So, Jeff and Adam, this has been a really interesting discussion on 3D printing and the process of additive manufacturing. What final thoughts would you like to share with listeners as we come to the end of this podcast?
For me, the most interesting piece of all of this is when we think about strategic value-add consulting and the operating paradigm that we've been in for roughly since the first industrial revolution and really solidified by the second industrial revolution, which was kind of the technical revolution that introduced the steam engine and electricity and the Bessemer process and interchangeable parts, and embodied by kind of the Model T assembly line. Our founder, Andrew Thomas Kearney, would have been one of the first generations to see Model Ts rolling out of Detroit. And I think our firm is a reflection of that paradigm. So when we say that the massive impact that additive could have and the coming together of all these different items of big data, advanced materials, and the potential that has to introduce a step change and potentially a third industrial revolution, we really need to rethink how companies operate, not being constrained by the services that we traditionally have done, like strategic sourcing, make versus buy, four walls improvement. Those things will have to evolve and shift with that step change. And being out in front of that and the ability to take advantage of that and being a first mover, in our opinion, just has a massive advantage.
And just as a quick anecdote to bring us to a close, I think it's important to think back to those gimmicky products that you mentioned earlier, Helen. So or that Jeff mentioned earlier, whether we're talking about the clothing printed at the Victoria's Secret fashion show or the houses that are printed in a day, well, those definitely seem like gimmicky products and gimmicky uses of additive manufacturing. I'd challenge you to look back to the 1990s and think about the use of the internet and how, if you asked somebody at that time, how valuable and how much time would you spend sifting through the internet to read everybody's every thought? And now fast forward to today and think about how much time people actually spend on Twitter, on Facebook, on WordPress. So that is something that really was not imagined as a huge game changer, was probably extremely gimmicky in the 90s, and now we're seeing people just spend enormous amounts of time doing that. And if we use that as the example, and if we use that as the framework, as additive technology advances, those gimmicky products might wind up being the pieces that unlock what the true potential in the future is. So let's not let our current operations paradigm limit our view of the possibilities of the future just because a few of the products today seem like they're a little gimmicky. Those gimmicks might end up being the starting point for the shifting paradigm.
Well, thanks very much, Jeff and Adam. Really lots of insight there and ideas about the future and how things are going to change. I'd just like to summarize what I've learned from this conversation on 3D printing and additive manufacturing. There are 5 things that stand out to me. The first one is that this really is a real game changer that's going to happen. It's a disruptor to the markets and industries out there that we currently know today. Secondly, Jeff, I think you pointed out it's not a new technology. It's been around for a while. However, we have a perfect storm brewing with the coming together of the software, the investment that big companies are making in 3D printing, and also big data plays a massive role here. Thirdly, the ability for unconstrained design. And fourth, the rapid prototyping and customization that is available that's really going to take off. And then fifth, Adam, you talked about, or you came with the example of reducing an aircraft engine by 1,000 pounds of raw material. So for me, from a personal perspective, additive manufacturing brings the concept, it's not as wasteful, and that's got to be of huge benefit for the sustainability agenda of process industries. So that brings us to the end of this podcast on 3D printing. I'd like to thank Adam Detwiler and Jeff Staub for being my guests today and sharing their knowledge of 3D printing with us. I'd also like to thank our production engineer, Tom Klein. Thank you for listening to this edition of The Wave of the Future. If you have any comments on this podcast or have a suggestion for a podcast topic that you'd like to see us cover, please share your thoughts via Twitter. Our Twitter handle is @ATKPAS. This has been an AT Kearney Procurement and Analytics Solutions podcast production. Join us again soon for our next Wave of the Future podcast.